To obtain the work done in the adiabatic process, let's start the computation here. In thermodynamics, we write the formula of the work done like this for quasi-static processes. Now, for adiabatic process, you might remember the equation is PV gamma is equal to constant. Here gamma is the adiabatic exponent, P is the pressure and V is the volume. So putting up the data here, at the place of P, I can bring here some constant divided by V2 power gamma. Let's say we call this constant as C. So the P is equal to C divided by V2 power gamma. This constant I am taking as C. Okay. At the place of P, we can put up the data C divided by V2 power gamma, and then here we are having the dV. This V2 power gamma, we are taking it to the numerator. C is a constant taken outside, V2 power minus gamma dV, and this is a simple integration. You might remember this x2 power n dx. What does it give us? X2 power n plus 1 upon n plus 1 plus some arbitrary constant k if we are doing the indefinite integration. So putting up the limits here, I am doing the definite integration, volume initial to volume final, V initial to V final. Now doing the integration using this analogy, C is staying outside. This integration will result in V2 power minus gamma plus 1. We can correlate at the place of n, we have minus gamma divided by minus gamma plus 1, V initial and V final. Okay. This I am keeping outside, C upon 1 minus gamma, and then putting up the limits. First we put the upper limit here. When we put upper limit here, this is V final and 1 minus gamma minus, now we put the lower limit here. So this is V initial and then 1 minus gamma. Do you agree with this expression? This is one expression for the work done by the gas in the adiabatic process. Although we can replace the things, such as if you want to replace, then what we can do here, let me rewrite the things. C upon 1 minus gamma I am keeping as it is. This I am breaking up like as Vf upon Vf2 power gamma. This minus gamma I am taking down this power. So it can be written like this, minus V initial power 1 divided by V initial power gamma. You agree? Now here we have C by V2 power gamma. What is C by V2 power gamma? C by V2 power gamma is the pressure. Look at this. C by V final to power gamma means we can rewrite this expression. Let me do that for you. We are rewriting this expression. 1 minus gamma. I am keeping here this 1 minus gamma. Now C by V final to power gamma. C by V final to power gamma will be P final, the final pressure. So here we will be left with P final, V final. I'll elaborate it again. V final is already here. We have kept it. 1 minus gamma we have kept here. Now C by V final to power gamma. C by V final to power gamma will be P final. Okay. Similarly, operating for this part, the negative sign stays here. V initial stays here. And C is getting multiplied to this expression also. So C by V initial to power gamma. V initial, then P should also be initial. So here we are left with P initial. So this is bit more familiar expression to remember. P final, V final minus P initial, V initial upon 1 minus gamma. This is the work done by the gas in the adiabatic process. And even we can deduce another format. We know the ideal gas equation. According to the ideal gas equation, we write PV is equal to mu RT, where mu is the number of the moles. So where we have written P final, V final, here we can write mu R T final. So the expression would look like this: mu R T final minus P initial, V initial would be the mu R T initial. So mu R T initial upon 1 minus gamma. Here if you require, you can take this mu R common for simplification purpose. So what will be the final expression if we take mu R common? Taking mu R common, the final expression would be T final minus T initial divided by 1 minus gamma. Let me write it a little bit bold. This is the final expression. Mu R T final minus T initial divided by 1 minus gamma. Okay, further expressions can be made. You can take minus sign common here as well as here. So how the expression would look like then? Mu R T initial minus T final upon gamma minus 1. So numerous expressions can be made. Hope you enjoyed it. Stay awesome. Take care.